All right, so welcome back to Mrs. Kemmer's Advanced Algebra 2 Flipped Classroom, and we are continuing on with Lesson 1.1. A lot of times the first lesson in each chapter tends to be very lengthy because you have a lot of definitions and concepts and whatnot. So here's part 2. Since it is another day, we have a new problem of the day that I want you to work on. So I'm going to read it out loud with you and then make sure you pause the video to solve all 4 parts to the problem, and we'll discuss it in class tomorrow. It's called a multi-step problem. The chart shows the average daytime surface temperatures on the planets in our solar system. Okay? And A, they want you to sort by temperature, list the planets in order from least to greatest daytime surface temperature. B, sort by distance, list the planets in order from least to greatest distance from the sun. C, find patterns. What pattern do you notice between surface temperature and distance from the sun? And D, analyze. Which planet does not follow the general pattern you found in part C? And here's all of our planets, still counting all 9 of them, even though, Pluto now tends to not be a planet, but let's go with the information. Book's a little bit older, okay? Make sure you pause and you answer all the questions before we move on to the actual lesson. Now, where we left off is example 3. It says use properties and definitions of operations to show this equation here is true. Quantity 10 divided by C times C equals 10 when C does not equal 0. Once again, you can't have 0 here because you see how it's divided by C? You can't divide by 0. So there's a little restriction on it in math to make sure it's completely true. And we're going to justify each step. So here we're going to use all those properties we learned in the last part of the lesson to write out a step and a reason why for each of them. The reason why are going to be our properties and definitions. All right, so here's where we started. And actually, I'm just going to pull this over here so I could sort of write below it. All right, now let's see how good I can write here. Once again, I'm still getting used to this. So the first thing we're going to do is, do you see how in the parentheses it says 10 divided by C? All right. Look back in your notes where you saw division. We only saw division in one spot, right? Well, and we're only going to change one thing at a time. So division can also be written as multiplying by the reciprocal, right? So let's change it here. I'm going to keep the 10, and actually I don't like the italics here. Let's see if I could change that out for this one. So parentheses 10 times 1 divided by C. Hopefully you guys are okay with the way I typed it. So we're changing it divided by C to multiplying by 1 over C. And we put the times C. All right, and usually we write equals 10. Now, when I did that, I'm going to put a couple spaces here. All I did is I changed it from division to multiplication. And if you look, that's the definition of division. We're just manipulating how it actually looks. Instead of dividing by C, it's multiplying by 1 over C. All right, now remember, you can do only one step at a time. In the end, we want them to get to equal 10. So we're not going to do anything with the right-hand side. We're just going to keep manipulating the left until it looks like the right. All right, well, I see I have parentheses. Well, why don't we group them differently? Let's try to get the C's together. So what I'm going to do next is write 10 times parenthesis 1 divided by C times C close parenthesis and equals 10. Oops. What changed here? You notice they're in the same order, right? But think about what property that is where we just changed the grouping. All right, you should get associative property of multiplication. Why have multiplication? Because we are multiplying them all. All right, so remember, we want to get it to look like the right. It looks like the left now. Well, I know if I multiply these, let's focus on the parentheses now that they're grouped together. Once 1 over C times C, they should cancel each other out, right? All right, and that's because, and I could write this off to the side for a second, and I'll erase it when I'm done. But 1, I'm going to write the fraction this way because I don't want to confuse you guys. Typing, I have to do the times C. Right? Really, C can always be over 1. So I'm writing this step out here. and we go cross cancel. We get 1. Does that make sense? Or you get C over C, which is 1. If you don't want to cross cancel, you'll get 1C over 1C, which once again leads us to 1. So these cancel out here, all right? So let's go back in our problem, all right? So we see how it equals 1, all right? So we're going to change it to 10 times, change this whole parenthesis just to 1. And I usually like to put some bigger parentheses here. And what I did here to get this to 1, think about what property is when it multiplies to 1. You should get the inverse property of multiplication, because they cancel each other out when you multiply. They're inverses of each other. Well, look, we're almost there, right? What's the last thing you need to do? We simplified the parenthesis until it's one single number. Well, now why don't I just multiply them? 10 times 1 is 10, right? Equals 10. And if you look at the property, you want to look at a property where you see here what's multiplying by 1. Think for a second. For this last part, you should get identity. Don't know why. That's weird. It's weird that my D key is not working. Not perfect for lessons. So make sure it's an identity. That's weird that doesn't work. Let's see if I can at least do this for now. There you go. How about that for now? Identity property of multiplication, and I'll figure out my laptop later. All right, how do I know I'm done? Because both sides, 10 equals 10. Give yourself a little practice. Make sure you try them. I know they're not that easy, but you know, practice makes perfect. Math is very important. We need to see how we get logically from one step to the other. When you solve an equation, you do that. Now we're just getting a little bit more formal with the terms. All right, so last major part of the lesson is going to deal with conversions. And these conversions, all right, I'm not going to read them out to you. You guys could pause the video and read through them. These are the ones you're going to need to know for a quiz or test. Obviously, there's other conversions as well. But we're going to go with these to solve some problems, all right? Now, some of these are just basic rate of change kinds of problems, so we don't really need conversions yet, all right? And let's go with example 4. Example 4, you work 8 hours and earn $60. What is your earning rate? What operation, think to yourself, do you do between the 8 hours and the $60? Think for a second. Pause if you need to. If we're looking at your earning rate, all right, rate usually is division. You're trying to find out how much you earn per hour. So let's see if I can write this out here. $60 divided by 8 hours. I promise as these videos go on, I'll figure out a better way to write. I'm using my MacBook and it doesn't have a mouse. All right. So if you take a look here, we're going to divide because we want to find out the actual rate between them. You should get $7.50 an hour. So $7.50 per hour. Per is division. I'm just going to write HR just because my writing skills are not great yet. So $7.50 per hour. All right, so some of these problems are common sense. What do you think you need to do to solve the problem? B, buy 18 gallons of gasoline at $2.65 per gallon. All right, so think about that. 18 gallons seems like a pretty big vehicle, probably like a truck. I mean, I know I have a little Honda Civic, and that only takes about like 10, 11 gallons, so it's pretty big. What are you going to do to find your total cost? Think for a second. You should have answered multiplication. So we're going to do 265 And units are very important. I mean, I know not always in the problem, but in the final answer, I'm going to be looking for them with you guys. So, it's multiplication. You get $47.70 is your total cost. And sometimes what I like to do is I usually like box my answers. Not always with easy problems. Like the more complicated they get, and my box isn't too great right now, but we'll work on that. All right. Now the last part here is example 5. We're going to perform the indicated operations, or excuse me, conversions. And you use that conversion chart to sort of figure out where you're going with everything. All right, so take a minute and read through them. Okay, so the first conversion we're going to take a look at is letter A, 120 feet to yards. So you want to take a quick look at our conversion sheet we have. So what I start off by doing first is I like to label all my units. So 120, we'll put feet, and I put the little letters, FT. And when I do my conversion with that equal sign, I'm going to put it in a big fraction. So that's a fraction. Once again, bear with me here. If we look at our conversion, what do we have with between feet and yards? Take a look. You should see 1 yard equals 3 feet. Now, in order for my units to cancel out, feet have to go in the denominator, right? Purely for the fact that this is numerator, this is denominator, they cancel out. So the number goes along with feet is 3, and then 1 yard. And when I solve them, I multiply across, I get 120. Now, don't forget to cross out the units. So 120 yard divided by 3. Which equals what? 40 yards. As my final answer, right? So this is our answer here. Okay. Now, something else we're going to take a look at. B, you'll notice since I last spoke, there's a metric conversion chart. It's something you learn in chemistry. It's the first place I've seen it. And we have units here we're going to start to talk about when you're going between metric system. Now, the one nice thing about the metric system is you pretty much just move a decimal to get your answer. There's no actual numbers to figure out. It's all a placeholder. All right, but with that being said, you do have to learn them. All right, so here's a way to remember. King Henry died unusually drinking chocolate milk. K stands for kilo, H ecto, D deca. Unusually is the unit, like meter, liter, gram. All right, D deci, C centi, M milli. So here's what we're going to start with. Here's 3.2, right? What do we have? We look at the prefix. We have kilo, right? All right. Kilo is K, so we started here. Watch how many places I have to move from here. We're going from kilo to centi. And whatever direction you move in, that's where you move your decimal. So we're starting at K for kilo. I'm going to go 1. Actually, let me do this a different way here. All right, so I'm going to go, start here. I'm going to go 1, 2, 3, 4, 5 places to the right. So what does that translate to, right? 3.2, I'm going to rewrite it down here. I'm going to move 1, 2, 3, 4, 5 places to the right. Now you might be saying, well, what are all these other digits? If you don't have anything, place zeros. So I have what? 320,000 centimeters. All right, and then we'll be ready for the next part in a second. All right, so we have two last examples where we just left off before I got cut off here was B, getting 320,000 centimeters. All right. Now, one little thing, I'm going to have this chart either at the end of the notes. I'm going to actually modify your notes before you actually get to it. I'm going to have it in the middle, right after the conversion sheet, for you guys to have this conversion. And in class tomorrow, we'll talk a little bit more about how to use the metric conversion chart. Like I said, the nice thing about the metric system is that you just simply move a decimal to the right or to the left. You don't have to worry about memorizing numbers. All right, it's a little more streamlined. All right, and like I said, I'll make this chart a little bit bigger as you follow along so you could read everything with it. All right, gives you little pointers too to help you out until you memorize them. All right, so now the next one, see, we're doing 3,500 ounces to tons. So I'm going to start with, let me see if I could type these. I might be better at that. All right. Then I'll put parentheses as I go here. Actually, I could do that here. You know, we don't really need parentheses yet. Okay, so here's my first number. Now, what I'm going to do next is I'm going to multiply it by the conversion. I want you to look at your notes and look at the conversion for ounces. Now, you might look at it first and go, hey, we don't have ounces to tons. Here we had feet to yards, but here we don't. Right. So you're going to have to look at a conversion, ounces to something else. So take a second and look. What you're going to find out is that we have a conversion for ounces to pounds. So up top, I'm going to see if this works a little bit better for us. I'm going to type 1 pound, so 1 pound, all right, over 16 ounces. And I'll explain that a little better in a second. Like I said, it's easier if I sort of type the words. All right. So we know 1 pound equals 16 ounces. Now, think to yourself, why did I put ounces in the denominator? All right, it matters. You can't put pounds in the denominator, you have to do ounces. Think to yourself, why? If you looked at the last example, we want the units to cancel out. All right, so we're going to be able to cancel out ounces here and ounces here. So that'll leave me with a number for pounds. All right, but we don't want pounds, right? The next part we're going to take a look at is our conversion from pounds to tons. And if you take a look, you do have a conversion there. All right, well, if pound is in the top, do I want the pound in the top or bottom? I want the pound in the bottom. All right, so the units cross cancel. All right, so 2,000 pounds. All right, and we look, what does that equal? It equals 1 ton. All right. So now I could cross out my units again. All right, well, pounds goes away. Cancel them out. We'll be left with tons. Remember, technically, when you multiply, and a calculator is going to make it a little bit faster for you, this is really 3,500 over 1. So we're going to multiply the numerators together. All right. I'm going to type it again. The numerator, 3,500, ton, over 3,200, just the number. And how did I get that? 1 times 16 times 2,000 is 3,200 or 3,200. So you see, once we know we're finished, we have just one set of units. Everything else cancels out. Last part is you're going to divide these. And when you divide them, sometimes we'll have to round. This one is one where we're going to round. I'm just going to round to the hundreds. You get 1.09 ton as our answer. Okay. That's our answer. Now we have one last one, 90 kilometers per hour to meters per second. So take a second, look up some units, and we will start it in a second. All right, so the last one, letter D. What's interesting about this one is if you read the problem, we have 90 kilometers per hour, all right? And that's going to be a little bit different because before we just had ounces or kilometers or feet to something else, right? So we had 1 unit, 2, 1 unit, 2, 1 unit, 2. Now if you look, we have kilometers per hour, all right? So let's see how we want to write it off originally. I'm going to write it as a fraction. I'm going to slide this up here a little. So I'm just going to rewrite it 90 kilometers. If it's already, I'm going to use km just because I know I want to make sure I have enough room. Per always means what unit or what operation, it means division. So per hour. And how I'm going to write that is with a fraction bar. All right. So this piece here translates to 90 kilometers per hour here. All right. So we're going to start with this one. And now what is interesting is here we had a single number, single number, single number. Now we have a fraction. So there's two sets of units we're going to have to change. I want us to start with kilometers. Kilometers goes here to meters. So look at your unit. You can look at the chart here in case you need help. You see it says 1 kilometer equals 1,000 units. So that's what we're actually going to use here. Let me try typing it again. So if I have kilometers up top, I ask myself, does kilometers or meters go up top? Meters is going to go up top, kilometers in the bottom. So let's try this again here. All right, so they're telling me that it's 1,000 meters over 1 kilometer. Then I'll draw my little line. All right, we're going to cross out the units as I go. We want kilometer, we have kilometer and meter. Kilometer goes in the denominator because now, whoop, watch this, kilometers goes away. All right, so now I have kilometers to meters. Well, now the other thing I have to worry about is hours. All right, so hour, I'm going to use my color pen here. Every time we just keep multiplying new units, I look what I have. I want to go from hours to second. Well, the first thing we're going to take a look at is, let's not go straight to seconds. Hours, then what's below hours? Minutes. How many minutes are in an hour? 60, right? Now, hours in the denominator this time. So if it's in the denominator, where does hour have to go? In the numerator to cross cancel or cancel out. All right. So we're going to say 1 hour. And we said 60 minutes. All right. So now I had hour in the denominator. I had to put hour in the numerator. Now they go away. The units are gone. So right now I'm left with minutes. Now if you take a look, minutes, we don't want minutes, we want seconds. So I think how many seconds are in a minute? Hopefully you remember 1 minute is equal to 60 seconds. And once again, units to cancel, denominator, numerator. Minute has to go in the numerator for these to cancel. So if we look, what are my units left? Meters, second. Meters, second. I'm ready for the answer. Last part, just like up here, but I typed it out for us. You put the numerator over the denominator. I want you guys to try this out on your own and pause it if you need to. Multiply, get one single numerator, get one single number for the denominator, and then we'll divide. What you should get, and I want you to check that you can get this, all right, is you should get 25, right, kilometers per hour. And I could also write it across like that. A lot of times, like we'll do miles per hour. Instead of writing a fraction, I write a division bar. And that's our answer. Make sure you take your time with these. I know they are not easy, and I know I can ask you a lot of different conversions. All right, and we'll get some practice. You'll have some problems in class to do in the packet, but I also have extra worksheets in our homework packets to sort of give you a little practice if you need it. All right, so let's go to the last one here. Finally, we are at the homework. All right, so I'm going to talk about that for a second so you guys get the hang of it. You have the problem of the day, answer, and explanation. You could do that right in the notes there. All right, and then 2, 3, and 4 are actually problems. They go in order. 2 follows our example where we're writing out each steps to go back to the notes. 3 is unit analysis. And then 4 is the indicate conversions, just like we had before. And be sure if you have any questions that you ask me tomorrow. All right. And that's it for lesson 1.1, part 2.